This video is going to be on adding and subtracting mixed fractions with different denominators, and I'm going to show you two methods. In this video I'll only show you one method, and then I'm going to redo the same questions in a second video, and you need to think about which method you prefer. I'm starting with this method because I think it's faster and it's much more efficient as long as you're quite good with your fractions work. So we'll see how you find it. Alright, let's have a look at the first example. We're adding two fractions together. 2 2/3 is being added to 3 1/8. So I'm just going to pick up my pen. And for me, with this method, what we're going to do is we're going to separate the whole number parts of each of the mixed fractions, and then we're going to also separately add the proper fraction, so the 2/3 and the 1/8. So the arithmetic is quite straightforward. So if we look at the blue parts, if we're going to add together the 2 and the 3, we're going to get 5, and now we can see that the denominators are not the same with the 2/3 and with the 1/8, so I'm going to form a common denominator. And if we take the 3 and the 8, the two denominators, my common denominator is going to be 24. I'm just going to put down the 24. Now to convert a denominator of 3 to a denominator of 24, I need to times, change my pen so this stands out, I have to times by 8. So whatever I do to the denominator, I will also do to the numerator. So the 2 gets times by 8, making a new numerator of 16. To go from 8 to 24 over here, I will times by 3. So I'm going to do that to the top, to the numerator as well, and 3 times 1 is 3. Altogether, I now have 5. Now, what I'm doing is I'm adding the whole number parts, which gave me the 5, and I'm also adding the two proper fractions. So that's why I have that plus sign over here. So once I add the 16 on 24 to the 3 on 24, I'm going to get 19 on 24. So it's 5 wholes and 19 on 24. So once again, what we're doing is we're adding the whole number parts and then we're adding the proper fractions. Let's try this method again with subtraction. Same exact thing, except for we will subtract the whole number parts. So we've got here firstly 6 and 3 for our whole numbers. When I subtract them, I'll get 3. And now I'm also going to subtract the proper fractions, and I'm going to add that to my whole number part here, which is 3. So I'm subtracting the whole number parts, I'm subtracting the proper fractions, and then I'm going to add those two quantities together. That's why I've got this plus sign over here. It's not a minus sign. I'm adding the whole number parts subtracted to the proper fractions subtracted. I'm adding those together. So I've got here 2/5 and 1/4, so I need a common denominator, and my common denominator, if I have 5 and 4, is going to be 20. And if I'm going to convert the numerators, what are we going to do? We've got 5 here. To go from 5 to 20, I'm going to times by 4. Do that to the top as well. Whoops. And that gives me a new denominator of 8. And then to go from 4 to 20, I'm going to times by 5 and do that to the top as well, which gives me a new numerator of 5. And then I can just add all my parts together. So I've got 3 wholes, and then I've got 8/20 minus 5/20. Well, that's just 3/20. Not many lines of working required as well when you try this method. Now, there's only 2 scenarios you need to consider where a little bit more work is required and your fractions work needs to be good. And the first one is where when you finish adding your whole number parts and your proper number parts, the proper fraction might actually become an improper fraction. So let's have a look at what I'm talking about. First, we're going to add once again the whole number parts. So we've got 9 and 6, add them together and we get 15. Then I'm going to form a common denominator with my two proper fractions. I've got 5 and 10, so my easy common denominator to go with, or my lowest common denominator, is 10. To go from 5 to 10, I'm going to times by 2, so I will do the same to the top, giving me 2 times 2, which is 4. To go from 10 to 10, no changes required. Now, that is the same as multiplying by 1. If you understand that that's the same as multiplying by 1, you'll understand that the denominator will then not change at all. So really I don't have to write in times by 1, sorry. So now we're going to combine all our parts together. I've got 15 wholes, and 4/10 plus 7/10 is 11/10. Now here is exactly what I was talking about before. This fraction here should be a proper fraction. So our mixed number is made up of a whole number part, which in this case is 15, and followed by a proper fraction. Well, in this case, we have an improper fraction. So what we need to do is change the improper fraction to a mixed number. So 11 on 10, 10 goes into 11 one time, remainder 1 on 10. Now remember, this is saying 15 and 11/10 means 15 plus 11/10. That's why I've put in this extra plus sign over here. Come on, stylus. So altogether I've got 15 wholes plus 1 and 1/10. That makes 16 wholes plus, or 16 wholes and 1/10. So just to finish off in that last line, I've added my 15 wholes and I've added my 1 whole there together to make the 16 wholes, and then the 1/10 just drops down. Okay, it is important that you understand you cannot finish on that line. Okay, that is an unfinished solution, and that's not a mixed fraction if it's made up of a whole number part followed by an improper fraction. It must be a whole number part followed by a proper fraction. All right, one more example to see us through, and this is the other scenario you have to consider, which is sometimes you'll get a negative fraction. Let's have a look at what happens when you get a negative fraction. So I'm going to subtract the 3 and the 2. Subtracting the whole number parts gives me 1. I'm going to form, first I'm going to put that plus sign because I'm adding the whole number parts subtracted, and I'm adding to that, I'll add the difference between these proper fractions. I need a common denominator for my 9 and my 3, so that's going to be 9. The 9 is already in the first proper fraction, so the numerator will be unchanged. To go from 3 to 9, I need to times by 3, so that'll give me 6 here, and I'm going to subtract them. Now, when I subtract, what I want you to notice is that 4 minus 6 gives me -2, okay, and that's where we're going to get a negative fraction. So we're going to get -2/9. You cannot have a mixed fraction with, or in your final answer anyway, you cannot have the fraction, the proper fraction, to be negative. So this is what needs converting. All we have to do is borrow from the 1 whole that we have. If you have a whole and you take away 2/9, then you'll be left with how many ninths? So a whole is 9/9. 9/9 minus 2/9 is 7/9, and that would be the final answer. So if you do end up with a negative fraction, you need to think, how do I borrow from this whole number part over here to then get my final answer? So that's method 1 of subtracting and adding mixed fractions. If there's anything you need to think about further, it might be a good idea to rewatch the video. I hope you enjoyed the video, and I'll post another video with my second method with the exact same questions.